Hello. This is Nico, and in this Science with Nico, we are going to take a look at polymers and polymerization reactions. Now, polymers, you're going to be most familiar as plastics. All right, polymers are a class of macromolecule, and by macro we mean big, but they find widespread use throughout society beyond just the application of plastics. The truth is, everything from the synthetic rubber in your shoes, the synthetic fibers in many of the clothes that are commonly worn these days by us, to the latex binder in the latex paint on the walls, are actually polymers that are most likely derived from crude oil. Okay, plus if we extend our definition of a polymer beyond polymers that are made from crude oil to include biological polymers, we actually are talking about many biological macromolecules, including proteins, polysaccharides, and even DNA. Alrighty, so what are polymers? Okay, now polymers are large molecules, and commonly when we first start talking about a polymer, we treat them like being a large singular alkane chain. Now this drawing I have here kind of illustrates a long alkane chain, but it doesn't really do a polymer justice, all right? Because a polymer can actually have somewhere in the line of millions, or if not multiple millions, of carbon-carbon bonds between carbon-carbon atoms. Okay, they can get really, really big. I've obviously just run out of room on the page. All right, now polymers are made up of smaller building blocks that are called monomers. Now, these monomers usually are a small hydrocarbon molecule like ethene just here, and they have some sort of functional group, such as a double bond. It's not always a double bond, but such as a double bond that can open up and allow them to react with each other, and that lets them form these long alkane chains. Now, with that being said, you need to be aware of some common monomers, all right, as we start talking about polymers. Now, we've already mentioned ethene, but we also know ethene by the older name, ethylene, and the important part of that structure is that double bond which actually opens up and allows those molecules to react together. Some other common monomers that you need to be aware of include chloroethene, also known by the term vinyl chloride. That's an older name for that. And again, if you have a look here, very similar structure to ethene. They both contain that important double bond that allows them to actually react together and form a long chain. But in this case, a single hydrogen has been replaced with a chlorine atom. And that changes the final properties of the polymer that is produced. Now, the polymer that's produced here, you would actually probably be quite familiar with, at least familiar with it in terms of its abbreviated trade name being PVC. All right, which is probably in your home as PVC piping associated with the plumbing of your home. Alrighty, they get everywhere, polymers. Now, we have another important monomer to be aware of. Just like ethene, we have propane, also known as propylene. That's an older name by which it's known by. And just like ethene, this molecule is a byproduct of the cracking of long-chain petroleum oils to form more useful fuels. And so basically, to actually meet our fuel requirements of society, the heavy requirements for fuel to actually run our modern society, we need to take some of the long-chain oils and we crack them. And one of the pieces we crack off them, when we crack it down to the size of a fuel molecule, is a alkene. And two of the most common alkenes are ethene and propane, and they find a large amount of use in the synthetic chemistry industry, and chiefly they also find a large amount of use in the plastic industry as monomers. And so it's worth being aware there. Take note that the key difference between this molecule, propane, and ethene is that one of those hydrogens has been replaced with a CH3 group. Alrighty. And finally, we have another monomer that is quite common to see, and this is phenylbenzene, most commonly known as styrene. And phenylbenzene is found in widespread use as a polymer, chiefly polystyrene if we talk about it in terms of its trade name. And that actually has a bunch of really good properties in terms of it being a material. It does have some negative impacts on the environment, but those properties are actually controlled by the presence of this ring structure here off the side. Now, if you have a look at this, it has, again, just like the other monomers, that important double bond that allows it to react and form a long chain. Off the side, it has an aromatic ring structure just here. And if you look at this, these are commonly drawn like this with these series of alternating double bonds throughout them. I wouldn't be surprised if you think, oh, you could open that up and make a chain, but that's not actually the case. This is a special structure that is really quite stable and quite difficult to open up. And what it actually does is it creates this polymer chain with these big, bulky organic groups on the side that actually are attracted to each other. And so these chains really like to stay together. And that lends some really interesting properties to them, all right, that sees them being able to be used from applications where a rigid hard plastic is needed, all right, for example, a CD case, to applications where if you actually expand them using a gas and create expanded polystyrene foam, they're really quite useful in terms of packing material as well. Alrighty, let's take a look at the two types of polymerization reaction we're going to be taking a look at, which is the first one of which is addition polymerization. So addition polymerization involves the reaction of monomers that contained a double bond. All right. For example, pictured above here, we have 3 ethene monomers. Now, if we actually do some chemistry and have them react with each other, they will form a long alkane chain, which we would call polyethene. All right. And in this case here, what's happened is each of these double bonds in these monomers has actually opened up and allowed them to react to each other. And that's addition polymerization. That's because we're adding to the double bond. All right. The second type of polymerization that we're going to take a look at today is condensation polymerization. Now, this type of polymerization does not involve a double carbon-carbon bond like addition polymerization. It involves the use of some slightly more interesting looking functional groups that are involved in the structure of hydrocarbons, commonly carboxylic acids, which is carbon double bonded to an oxygen with an OH group and an alcohol, all right, and sometimes possibly even an amine as well. All right, and in the case of these polymer reactions, you typically have 1 to 2 different types of monomers, all right, because you are reacting different functional groups together. And what happens is these functional groups actually react and a small molecule is removed when the monomers react together. And so in this example here, we're actually talking about the formation of a really quite common polymer, all right, that you would actually quite commonly know by the shorthand name PET. All right, and what happens here is, to start with, those two monomers will react together and they will eliminate a small water molecule. And then again and again, they will keep the other monomers that are in the reaction mixture will react together. And eventually you'll just have all of these molecules that are made up of 2 monomers called dimers, which then will start reacting together and you'll end up with a long chain. Now in this case here, the key difference is that a small molecule is removed from the chain. Normally a water molecule, but it can be other small molecules. Sometimes it's a small molecule like hydrochloric acid. All right, and that's removed from the polymer chain. And that actually is why they're called condensation reactions, because you're removing water from the chain. Alrighty. It's time to take a look at a challenge. Here is a question for you to do at home. Okay, so in this challenge, the way I suggest that you do it is after I go through what's expected of you, you hit pause, give the question a go, and once you have done that on some paper at home, hit resume and I'll go through the answer with you. All right, so in this challenge, given 3 chloroethene monomers, draw the polymer chain that would form via addition polymerization. Okay, so we can see that just here we have our monomer chloroethene. So just remember, this is a question for you to have a go at. All right, so hit pause. Don't forget, hit pause. And once you've given it a go, come back to it and I'll go through the answer with you. Okay, so I'm going to assume that we're coming back from you giving this a go yourself. What happens here is that our chloroethene molecules, they react together, the double bond opens up, and they form a long chain like so. And what happens is the position of the chlorine atom on every second carbon is actually preserved, because if you have a look at the monomer, every second carbon, in this case here, that's carbon 1, that's carbon 2. Carbon 1, carbon 2 has a chlorine atom on it. And you can see that down here in the resultant polychloroethene chain that is formed just here. All right, where every second carbon has a chlorine molecule. We'll get into that, into both addition polymerization and condensation polymerization more in greater detail in some later videos. Okay, let's take a look at some polymer reaction shorthand before we wrap this video up. Now, as you would probably appreciate right now after doing that challenge, drawing a polymer chain, because it's so big, if we want to include a decent number of monomers, can be a bit of a pain in the butt, just because that's a lot of drawing of monomers as we draw a long chain. And we run into issues because we're still not representing that chain particularly well, because they can be so big, they can be millions of monomers long, and we run out of room on the page. So chemists have actually come up with shorthand to better represent a polymer chain. All right, and they do this using the following type of reaction. Okay, and so in this case here, we have ethene reacting. All right, so we have an ethene monomer, and we have N ethene monomers reacting together. That's where N equals many. And they react to form the repeating unit of a polymer chain. So when we have ethene, that same chain repeats itself over and over and over, and we have N repeating chains, which is equivalent to the number of monomers that we have. And that's a different way of representing a polymerization reaction. Okay, it's time for another challenge just as we wrap this up. Alrighty, so we have here a new challenge. Using the shorthand that we just discussed, you are to draw a polymerization reaction for propane. Alrighty, so just like the last one, hit pause, give it a go yourself at home, and after you've done that, hit play and I'll go through the answer. Now don't forget, hit pause and give it a go yourself. Alrighty. Let's go through that answer just here. And so here what we can see is we have our propane molecule, okay, our propane monomer. And here you can see it's got that important double bond that lets it actually act as a monomer and bond to itself. And it has that CH3 group that makes it differ in structure from a ethene molecule. All right, and because we have many of those monomers, we have brackets around it, and we put an N out the front, and they react together to form N repeating units. Again, notice when we have our monomer here, the position of the side group here, in this case the CH3 methyl group, is preserved on the repeating unit of the chain. And because there are many repeating units, that is also to the N repeating units. And that monomer just there, that monomer would be called polymerisation. polypropene. Okay. And so it's time for us to wrap this video up. And let's just take a look in review. All right, so in this video, you have learned what polymers are, some common monomers, and the structure of those common monomers. You have briefly been introduced to addition polymerization and condensation polymerization, which we will be exploring in greater detail in later videos. And you have been introduced to shorthand for drawing a polymer reaction. That means you can more accurately represent the many number of monomers involved in making these long chain molecules. Thank you for watching. If you have any questions, don't hesitate to leave a comment down below or to chat to me in class. Bye.